Hello, welcome back to my YouTube channel. So now we are going to discuss about Anova one-way classification. Okay, so Anova one-way classification in the sense in one-way classification, we take into account, that means we consider only in one direction, only one direction. That means either column wise, or row wise. Okay, row wise. Or else we can say this definition in another way. In one-way classification, we take into account only one variable, or else we can call it as a factor. So that is called as Anova one-way classification. One in the sense only one variable we are going to consider. That means only one direction. Either it may be row wise or column wise. Let me tell one example. For example here, so one plant is there. Okay, so we are considering here only two variables. That means, see, the plant growth depends on many things. Either it may be soil, temperature, okay, water facility, fertilizers. So like this, many factors the plant growth will depend. But I don't consider all those. Here, in one example, here they have given soil fertility and this side they have given water facility. Okay, but I don't consider what the soil it is. I just consider how the water facility is. That means only one factor I am going to consider. I don't want this one. So that is called as, so water is in row wise data. Okay, but soil is in column wise data. But I don't consider this soil. I only consider this water. Okay, so that means we have to consider only one variable, or else you don't consider water, you consider only soil. Okay, so that is called as Anova one-way classification. So Anova one-way classification in the sense what? We consider only one direction. Okay, either it may be row or else column. Okay, so now let us see. Now let us see the procedure of Anova one-way. So let me consider, okay, let us consider that n observations we are having. Okay, so they are denoted with xij, where I equals to 1 and so on up to k, comma j equals to 1, 2 and so on up to n of a random variables. So let me show in the table format. Here x11, x12 and so on, x1, n1, and next one is x21, x22 and so on, x2, n2 and so on like this. And the next one is xi1, xi2 and so on, xi, ni. Okay, so like this I have given the data. So as I told this, Anova one way depends only in one direction. So that's why here I am going to analyze only in one direction. First we have to do mean. So mean in the sense it is denoted with x1 dot bar. Okay, x bar 2 dot and so on, x bar I dot. So why I have kept here dot? In the sense we are doing only one direction. So the second direction we are not going to do the analysis. It indicates that only we are doing one direction. That is row wise we are doing, column wise we are not doing. It indicates. Okay. So next, null hypothesis. Null hypothesis. So null hypothesis means here population means are equal. So we are going to consider that population means are equal. That is H naught such that null hypothesis is indicated with H naught such that mu1 equals to mu2 equals to and so on equals to mu k. Okay, or else H naught such that alpha 1 equals to alpha 2 equals to and so on equals to alpha k. Okay, so this is null hypothesis. And alternative hypothesis, what we have to do is we have to contrast for null hypothesis. That means opposite for null hypothesis. Here we are considering all populations are equal. So here we have to do what? Populations are not equal. Okay, populations means are not equal. Not equal. So that means what? We have to keep here not equal to symbol here. Okay. So and the next is mathematical model. So and the next one is mathematical model. So mathematical model. So the linear mathematical model is the linear mathematical model is xij equals to mu plus alpha I plus epsilon ij. This is equation 1. Please don't call it as eij. This is epsilon. Okay? Or else in some books, xij, instead of xij, it may be written as yij also. Nothing wrong in it. Okay? So, where mu equals to, we call it as a general mean. Okay? Or else we can call it as a overall mean. Overall mean. And the next is epsilon ij. This is error effect. Error effect. And the next is alpha I. Alpha I is called as additive effect. Additive effect. So we can write alpha I mu I minus mu. We can write. Okay, so this is about mathematical model. So the equation will be in this format. Now we have to do statistical analysis. Okay, now what we have to do is we have to do statistical analysis. Statistical analysis. So statistical analysis in the sense Here first we have to consider this equation, that is xij equals to mu plus alpha I plus epsilon ij. This is equation 1. Okay, so we all know that mu and alpha we have to estimate. So in order to estimate unknown parameters, we have to use one method that is called as principle of least square method. Okay, so by using principle of least square method, we are going to find out mu and epsilon, mu and alpha. Okay, so here mu and alpha I can be estimated by using principle of least square method. Principle of least square method. So what is the principle of least square method definition? That is nothing but summing and squaring between observed and expected values should be minimum. Okay, so this is the definition for principle of least square method. Okay, so by using this definition we are going to write this equation, that is nothing but E equals to summing, here we told now summing and squaring. So that's why what we have to do is epsilon ij square. Okay, here I limit and here j limit. Okay, so from equation 1, so what is epsilon ij? That is nothing but, here you see epsilon you keep here and these two terms you bring this side, so that what we'll get is epsilon ij equals to xij minus mu minus alpha I. Okay, so we are going to keep this value in this term, so that is E equals to summation, double summation, xij minus mu minus alpha I whole square. This is equation 2. So now in order to estimate mu and alpha I, we have to differentiate equation 2 with respect to mu and alpha I. Okay, so now differentiate the above equation. Now differentiate the above equation 2 with respect to mu and alpha I. We get what we get? We get dou E by dou mu equals to 0 and dou E by dou alpha I equals to 0. So first we have to consider this one. Dou E by dou mu equals to 0. That implies dou by dou mu. So what is E? Here we have considered this equation. Okay, here we have E value, we have to write this one. So that is nothing but double summation I j xij minus mu minus alpha I whole square equals to 0. Okay, so here we have to do the differentiation with respect to what? Mu. So that's why we have to, this is in the form of what? X square. So x square differentiation derivation is nothing but 2 into x to the power of 2 minus 1. Okay, so that's why here what we have to do is 2 into double summation xij minus mu minus alpha I whole to the power of 2 minus 1. With respect to mu we are doing no. So what is the coefficient of mu? We are having minus 1. So that's why minus 1 equals to 0. So these two we are taking right hand side. So 2 into 0 is nothing but 0 we'll get. So that's why summation I summation j xij minus mu minus alpha I 2 minus 1 is nothing but 1 equals to 0. Already this 2, this minus 1, nothing but minus 2. So minus 2 we have taken to right side. So it becomes 0. So the remaining factor is this one. So now what we have to do is, we have to multiple these summations with these terms. So we get double summation, that is xij minus double summation mu minus double summation alpha I equals to 0. Okay, so these both terms we are having negative values. If we take these two terms to the right hand side, we'll get the positive values. So double summation xij equals to summation double summation mu plus double summation alpha I. Okay, so now what we have to do is double summation xij equals to summation. Instead of this summation I am going to keep n. Why? Because summation j equals to 1 to n, this limit is. So here we have to think that here we are having 1. Okay, we have to think that here we are having 1. So that means if we take this summation, in place of 1 you can keep n. So that's why I took this summation and I kept here n mu plus double summation. Again, this one also what we have to do is, this one again we'll, instead of this summation we'll keep n alpha I. Okay, so in these both terms what is the common term we are having is summation n. So double summation xij equals to double summation n we are taking common. So mu plus alpha I. Okay, so again this summation n, we are having one formula, capital N equals to summation small n. Why? Because this is population, these are samples. If we add all samples, we will get the population itself. So that's why instead of this one, we are going to keep capital N. So double summation xij equals to capital N mu plus alpha I. So we bring this capital N to this side. So what we get is 1 by capital N double summation xij equals to mu plus alpha I. Okay, so 1 by n double summation xij equals to mu plus, what is the value of all alpha I? This is additive effect we have considered in the starting of this video. What we considered alpha I value is nothing but mu I minus mu. So that's why this both the values gets cancelled. Okay, so therefore mu I equals to what? 1 by n summation xij. So now we got the value of mu I. So again, now what we have to do is, this value is nothing but mu I equals to x bar double dot. That means here two directions, overall mean we call it as. So overall total, that means row total, column total, that is called as overall total. So mu I is nothing but overall mean, no? So that's why So this value can be written as x bar double dot. Now consider this one, dE by d alpha I, or else dou epsilon by dou alpha I equals to 0. So derivation of alpha I, E instead of E, what we have to write is this one. Okay, so double summation xij minus mu minus alpha I whole square equals to 0. Okay, so and the next we have to differentiate with respect to what? Alpha I. So d by dou alpha I, here what we have written? Double summation, but here I am going to write only summation j equals to 1 to n xij minus mu minus alpha I whole square equals to 0. Why we have to consider only one summation? We are having two summations. Why we have to consider only one summation? In the sense, here we are doing only one way analysis. So that's why we have to take only one summation. Okay, so we should not take both the summations. Then why we have taken here both the summation? Why? Because here overall mean means rows and columns total is called as overall mean. So that's why we have taken here double summation, but in this we are taking only one summation. Why? Because this is either column wise or row wise. So that's why we have to do only one summation. So 2 into summation j equals to 1 to n xij minus mu minus alpha I all to the power of 2 minus 1 with respect to what we are doing differentiation? Alpha I. So that's why alpha I coefficient is minus 1. So that equals to 0. 2 into minus 1 is minus 2. So if we take that side, we'll get 0. So summation j equals to 1 to n xij minus mu minus alpha I, 2 minus 1 is nothing but 1 equals to 0. So now what we have to do is we have to multiply this summation with all these terms. So summation j equals to 1 to n xij minus summation j equals to 1 to n mu minus summation j equals to 1 to n alpha I equals to 0. So these both terms are having what? Negative values. So if we take to right side, it comes positive. It becomes. So summation j equals to 1 to n xij equals to summation. This mu we have to take as constant. Here we are having 1. We have to consider. Nothing is there means 1 will be no. So place alpha I. So alpha I summation j equals to 1 to n 1. Okay. So summation j equals to 1 to n xij equals to mu into. So this whole total we have to consider what? N. Place. And this one also n. So alpha I n. So here we have to take common n. So mu plus alpha I will get. So summation j equals to 1 to n alpha ij. Okay. So now this one we have to bring this side. So 1 by n summation j equals to 1 to n xij equals to mu plus alpha I. So therefore alpha I equals to 1 by n summation j equals to 1 to n xij minus mu. So we all know that what is the value of mu? X bar double dot. Okay, so therefore alpha I equals to this formula is x bar I dot. Why? Because here we are doing only one way analysis. So that's why I we have to keep. If we are having j limits, I will keep. If we are having I limits, we have to keep here j. Okay. So minus x bar double dot. So this is the value of alpha I. So now substitute mu alpha I values in equation 1. So equation 1 is nothing but xij equals to mu plus alpha I plus epsilon ij. So xij equals to, what is the value of mu? X bar double dot plus, so alpha I value is x bar I dot minus x bar double dot plus epsilon ij. So these both values gets cancelled. So xij equals to x bar I dot plus epsilon ij, but we want the value of epsilon ij. So epsilon ij equals to xij minus x bar I dot. Okay. So this is the value of epsilon ij. So again substitute mu alpha I epsilon ij in equation 1. So what is equation 1? Xij equals to mu plus alpha I plus epsilon ij. So xij equals to mu value is x bar double dot plus alpha I value is x bar I dot minus x bar double dot plus epsilon value we got xij minus x bar I dot. So xij minus x bar I dot. Okay. So finally we bring this term to this side. So xij minus x bar double dot equals to xi bar dot minus x bar double dot plus xij minus x bar I dot. So now what we have to do is, don't cancel these both terms. We should not cancel after substituting mu alpha I epsilon ij in equation 1. We should not cancel. Why? Because here we are going to find out the effects. Okay, so that's why we should not cancel this both. So now applying summing and squaring. Summing and squaring. So summation I equals to 1 to k, j equals to 1 to n, xij minus x bar double dot whole square equals to double summation I equals to 1 to k, j equals to 1 to n, xi dot bar minus x bar double dot whole square plus double summation I equals to 1 to k, j equals to 1 to n, xi j minus x bar I dot whole square. Okay, so this one we call it as total sum of squares, or else we can write it as st square. Okay, this one we call it as sum of squares of groups, or else we can write it as sg square. So this one is SSE, sum of squares of errors, or we can write it as SE square. Okay, so now degrees of freedom. So degrees of freedom, total TSS, total sum of squares follows n minus 1 degrees of freedom. Okay. So next, group sum of squares GSS or SSG follows k minus 1 degrees of freedom. Okay. Next, error sum of squares follows capital N minus k degrees of freedom. So, and the next is mean sum of squares. Mean sum of squares is the formula for mean sum of squares for total equals to st squared by n minus 1. Okay, for group sg squared by k minus 1, and for error SE square by n minus 1. So these are the formulas. And last, test statistic. Test statistic. So test statistic, F calculated equals to SG square by SE square, or else SE square by SG square. So which is greater, we have to keep it in numerator. So that's why we can write or. So conclusion, and the final step is conclusion. So F calculated is less than or equals to F table. We have to accept null hypothesis, otherwise we have to reject. So this is about Anova one-way classification. So this is very important question. So in exam, if they ask about statistical analysis, write about statistical analysis of one way, you have to write the same. Mathematical formula for analysis of one way, you have to write the same. So whatever they ask, if you find Anova one way, you have to write the full. Okay. So thank you for watching this video. And if you are newly watching this video, please don't forget to subscribe my channel. So like, share. Thank you. Have a nice day.